Okay, those of you that are absent on Friday, there were a handful of you that were absent on Friday. So we're going to go over the lesson that's on Friday, and it's on the parabola. And we're talking about the geometric definition of a parabola, because this unit, we're going over conic sections, and conic sections are sections of, and I'll show you a video later, but it's basically two cones, and then a plane is intersecting the cones. And then you have different graphs depending on where the plane intersects the cones. So the first graph we're going to be talking about is the parabola. Now, if you follow along, it says the parabola is the collection of all points P in a plane that are the same distance, D, from a fixed point as they are from a fixed line. The point is called the focus of the parabola, and the line is the directrix. Okay? So right here on this blank space, it says, as a result, a parabola is a set of points P for which the distance from the focus to any point is equal to the distance from that point to the directrix. Okay? So basically what it is, it's distance to the focus is equal to distance to the directrix. And we went over this in Algebra 2, so we're going to see it again here. Now, if you look at your paper here, this is an example of a parabola. And then you can see that, first of all, you know that the parabola, this is the axis of symmetry, because the parabola folds upon itself at the axis of symmetry. Now look at the vertex. The vertex of the parabola will always be halfway in between the focus, which is this point here, and the directrix. Now any point that's on the parabola, so for example, look at this point here, it's the same distance to the directrix as it is to the focus. Anywhere on this parabola, so this point here, the distance to the directrix is the same as the distance to the focus. Okay? Now, for this class, the distance from the focus to the vertex, we are going to call A. Okay? So, please take note that A is equal to the distance from the vertex to the focus. Okay? So if you look back at this drawing, the distance from the vertex to the focus is A, but that means since the vertex is the same distance to the focus as it is to the directrix, the distance from the vertex to the directrix is also A. So, which means the distance from the focus to the directrix is 2A. Okay? Now, we are going to use this information to help us derive an equation for a special type of parabola. So now we're going to go in the bottom section where it says analyze parabolas with vertex at the origin. And it says if we choose to locate the vertex V at the origin 0, 0, we can conveniently place the focus on either the x-axis or the y-axis. Okay? So in this case, we're going to consider the case where the focus is on the positive x-axis. So, on the bottom left here, let's draw a picture. Okay. So here's our coordinate system, and we're going to make the vertex the origin here. Okay. Now it says that we can place the focus really in anywhere of the axes. I could place it here, 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 or here. But for right now, we're going to do a special case where the focus will be on the positive x-axis. So let's make the focus right here. And of course, if the distance from the vertex to the focus is a, the coordinates of the focus is going to be a 0. Okay? See that? But the focus there is a 0. Now, if the distance to the focus is a, and it's in the positive x direction, the directrix has to be in the negative x direction. And the distance is still going to be a. So your directrix is going to be right here. And it's going to have the equation, so your directrix has the equation of x is equal to negative a. Okay. So now, if I draw my parabola, and we learned this in geometry, and we also learned this in algebra 2, but remember, the parabola will always hug your focus, okay? Your parabola should never intersect your directrix. So the way your parabola is going to look like, it's going to look like something like this, okay? And I know this is a different parabola than we're used to seeing. We're used to seeing parabolas that open up or open down, but now this is a parabola that opens right, okay? Now, this parabola is not a function because it doesn't pass the vertical line test, but it still is a parabola. Now, remember, let's find a formula for this parabola. Okay? One thing to know is we know that the distance to the focus is equal to the distance to the directrix. We have that from before. Okay? Now, remember in algebra 2, the way to find distance is to use the distance formula. So, let's take any point here. Remember, the distance to the directrix is going to be the same as the distance to the focus, right? Now, let's just call this point on the parabola x, y, okay? And let's do the distance formula. So now, if we're going to do the distance from the focus to the, from the point to the focus, it is going to be the square root. And remember, x2 minus x1, so it's going to be x minus a squared plus y minus 0 squared. Now, we're only going to do this derivation one time. And then from when we do the examples, you don't have to go through this step. We're just going to derive the formula that we're going to be using every single time. Now, the distance to the directrix, if I do the distance formula, is going to be x minus negative a squared. Because remember, the x value here is negative a. So the distance from this point to this point is x minus negative a. And then this point here is really negative a y, right? It's on the same y value as your point. So your second term here will be y minus y squared. Okay? That's the distance formula. Now, if I have square roots on both sides, the best thing that we could do is we could square both sides. Okay? If we square both sides, the square roots remove, and I'm left with x minus a squared. And now y minus 0 is just y, so I'm going to have y squared. And this is going to be equal to the square root. This x minus negative a becomes x plus a squared. And then y minus y is 0. Whoops, there's no square root here anymore. Okay, we squared both sides. Now this just becomes binomial multiplication. X minus a squared is really x minus a times x minus a. If you want, you could do it on the side here, but I'm just going to go ahead and write out what the binomial multiplication is here. It's x squared minus 2ax plus a squared plus y squared. And now x plus a squared is equal to x squared plus 2ax plus a squared. Okay. However, if we have common terms on opposite sides, they could cancel. So my x squared and my x squared cancel, and my a squared and my a squared cancel. And what I'm going to do is I'm going to leave my y squared on the left side, and I'm going to bring the like terms to the other on the right side. So my final equation here is y squared is equal to 4ax. And now this is the formula for a parabola with the vertex at the origin and the focus to the right of the parabola. Y squared is equal to 4ax. So now let's turn the page, and we are going to do look at the equation of a parabola again. Okay? So hopefully you have this down on the bottom of the first page. So now we're on the second page, and now it says on the top the equation of a parabola with vertex at 0, 0, focus at a 0. So we're just going to write the formula again. Y squared is equal to 4ax. I wanted to put this up here so you have it for the rest of the page. Okay? But this is the formula that we're using if the vertex is at 0, 0, and our focus is to the right of the vertex. So now let's move on to the... so write that in the first blank spot there. Then it says, recall that A is the distance from the vertex to the focus of a parabola. When graphing the parabola y squared is equal to 4ax, it is helpful to determine the opening by finding the points that lie directly above or below the focus a0. And then it says what happens to our equation. Now, because we are going to be graphing parabolas, it's actually kind of important for us to know more than just the vertex and the focus. We have to know other points on the parabola. So we're going to learn something new that we didn't learn when we first did parabolas. Okay? So let's draw the parabola that we had from the first page. Okay? We had the vertex here. Our focus was to the right. And then our directrix was over here. So redraw the figure maybe on the empty left space right here. Okay? And remember, the focus is at a0. Now, if that's our parabola, we are actually going to talk about something new. Here's our focus. Okay? We are going to find two more points on this parabola, and the way we're going to find it is we're going to go directly above and directly below the focus. Okay? Now, why do that? Well, if this is the equation for a parabola, y squared equals 4ax, that means that anywhere on the parabola is going to satisfy this equation. Okay? Now, however, at the focus, if I go up or down and I end up at these points, the x value is the a value of my focus. Okay? So once again, in this parabola are all of my x and y's that satisfy this equation. But if I'm directly above or below the focus, my x value is a, right? It's a and some y value, and it's a and some negative y value. Okay? So it says, what happens to our equation? Well, if that's our equation, y squared is equal to 4ax, I can replace x with a, because that is the x value at the focus. So at these points, x is a, so this becomes y squared is equal to 4 times a, which becomes y squared is equal to 4a squared. Now, if I solve for y, I'm going to square root both sides. And so y, and since it's an equation, I need plus or minus 2a. Okay? So, to find these points, okay, it's plus or minus 2a. Now, the line, so as you can see in this next little small paragraph, the line that connects the points above and below the focus is called the lattice rectum. Okay? And so see, if this is 2a and this is 2a, the lattice rectum is actually length of 4a. Okay? Now, let's actually do an example. And hopefully when you see the example, you'll be like, oh, it's not too bad. Okay? So example 1. Example 1 says, find an equation of the parabola with vertex at 0, 0 and focus at 3, 0. Graph the equation. So, I know my vertex is at 0, 0 and my focus is at 3, 0, so I know my vertex is, I know the focus is to the right of the vertex, so I'm going to use this equation. So, this equation we will only use when my vertex is at the origin and my focus is to the right of the vertex. So here's my equation, y squared is equal to 4ax. Now, so you have a graph here, so let's actually utilize it for a minute. If my vertex is at 0, 0 and my focus is at 3, 0, then what is my a here? My a is just the distance from the vertex to the focus. So in here, a is equal to 3. So this equation becomes y squared is equal to 4 times 3x. And so y squared is equal to 12x. And that is my equation for the parabola. You do not need to solve for y. That is the form that we actually kind of want to see. Y squared is equal to 12x. Now, we don't know exactly, now we want to be more accurate in our graph, right? So we're actually going to calculate the lattice rectum part of this equation. Now remember, the lattice rectum occurs when the x value is equal to the focus. Okay? So we are going to use the x value of my focus. Since my focus was at 3, 0, I am going to use for the x here, x is equal to 3. So this becomes y squared is equal to 12 times 3. Okay? And I'm going to put here again, the lattice rectum is what we're doing here. This one, x is equal to a. Okay? So now this becomes y squared is equal to 36. I square root both sides, and I get y is equal to plus or minus 6. So that means that if this is my focus is at 3, 0, my lattice rectum is going to be at my focus, but it's going to be 6 up and 6 down. So let's complete the graph here. Here's my focus. If I go 3 behind, it's the directrix, because remember, distance to the focus is equal to distance to the directrix. And then I'm going to go 6 up, and that is going to be, I'm going to pick the point that's directly above the focus, and I am going to go 6 down, and I am going to go 6 directly below my focus. So my parabola will look like that. Okay, remember, it hugs the focus. So that's how you do one of these problems. You find a, you plug it into the equation to get the parabola equation. To find the opening, you just take the lattice rectum, or the x value is equal to the the x value of your focus, and then you just go ahead and you solve for the lattice rectum, and that will be your positions on the parabola. Okay? So now, why don't you take that and try the DIY on your own. So pause the video so you could actually do this one on your own. So the DIY is exactly like the one before. This time you have a parabola with focus at 4, 0 and vertex at 0, 0. So you know that once again it's going to have this form. So y squared is equal to 4. Well, you know that if the vertex is at 0, 0 and the focus is at 4, 0, then you know A is equal to 4 here. Okay? So this becomes 4 times x. And so my equation is y squared is equal to 16x. Yeah. Now to find the lattice rectum, we just take our x and we put the A value of our focus. Now the focus is at 4, 0. So we are going to use this for A. Okay? So my lattice rectum is y squared is equal to 16 times 4. And so this becomes y squared is equal to 64. And if I square root both sides, I get y is equal to plus or minus 8. Okay. So if I graph this, my vertex is at 0. My focus is at 4, 0. My directrix is at negative 4, 0. And I know I didn't give you enough room on the paper, so that's my fault. But I know I go 8 below and 8 on top. And so my parabola should open something like that. Hopefully your parabola looks nicer than mine because you have the grid lines there. Okay. Now, if you look at example 2 we actually did in class where we graphed it on a graphing calculator. Now, one thing that you have to know is that since it's in the equation of y squared is equal to 16x, so for example, example 2, you want to graph y squared equals 12x on a graphing calculator. Now, because the graphing calculator has it in when you graph, has it y equals, whenever you have an equation like this, you have to solve for y. So this is the only time we'll be actually solving for y. So I square root both sides, and I have y is equal to plus or minus square root of 12x. That means when you open your calculator, you're going to enter two equations. y1 will be square root of 12x, and y2 is equal to the negative square root of 12x. You have to enter these both in order to get the full graph. Okay? So now let's do example 3. Okay. Example 3, we have to analyze the equation y squared is equal to ax. Now, if I have y squared is equal to ax, this equation, y squared is equal to 8x. I know this equation is in the form of y squared is equal to 4ax. Right? Now, what is a though? Well, if there's an 8 here and I have 4a, all I do is I do 4a is equal to 8. And I get a is equal to 2. So since it's in this form of y squared equals 4ax, I know a couple things. I know my vertex is at 0, 0. And since it's in this form, I know my focus is to the right of it. And since a is 2, my focus is at 2, 0. And if my focus is at 2, 0, my directrix is 2 in the opposite direction. So my directrix has the formula x is equal to -2. And so we have all that information. Now let's just find the lattice rectum. Okay, so if my equation is y squared is equal to 8x, remember we just look at our focus, and whatever this value is here, we're going to plug it into x. So this becomes y squared is equal to 8, well, it's 8a, so y squared is equal to 8 times 2. So y squared is equal to 16. And if I square root both sides, I get y is equal to plus or minus 4. So if I draw my graph, the vertex is at 0, 0. My focus is at 2, 0. But I know, well, first I know my directrix is at -2. X equals -2. And above the focus, I know my lattice rectum goes from 4 to -4. So my parabola will open up like that. Okay, now we've only dealt with one type of parabola, and it's where the vertex is at the center and the focus is to the right. However, not all the time the vertex, if the vertex is the center, the focus will be to the right. The focus could be to the left, the focus could be up, or the focus could be down. So now let's look at all possible scenarios. So what we're going to do now is we're going to see this blank, well for you it's blank. We're going to take that and we are going to go ahead and look at all the examples. Okay. So now you should have room so that you have space for 4 different graphs here. So the first graph is the one that we've been dealing with all this time. If here's your xy coordinate plane. The first graph is where the vertex is at the origin. The focus is to the right. And I know my directrix is at -a. And I know my parabola opens up this way. And your equation here is y squared is equal to 4ax. Okay? Now, case number 2 is instead of the focus being to the right, the focus is to the left. So, here's case 2. Case 2, here's my vertex. Okay. But now the focus is at -a, 0. Hopefully you could see that. It says -a, 0. So my directrix is now going to be at +a. And so my parabola is going to open up to the left. And this time, the equation actually has the same form, except since it's the opposite direction, we will include a negative. So the equation here is y squared is equal to -4ax. Okay. Now let's go ahead and look at the other cases. So here's case 3. Case 3 is where this is my vertex. My focus is at 0a. So now my focus is above. And my directrix is at -a. So now, the equation for the directrix, instead of x equals, it's y equals. And this parabola opens up. Okay. Now, this looks like a normal parabola that we've done before. And so the equation here is x squared is equal to 4ay. Look, it has the same exact, it looks exactly the same as the y squared, except it has x squared. And remember, when we first did parabolas, we did y is equal to x squared plus 2x plus 3. X squared was, x term was the one that was squared, and it opened up or opened down. So if I look at this equation, this is x squared, and where everything's positive is where it opens up. Okay? So the last case, obviously is the one where your focus is down below. Okay. And your directrix is at y is equal to a. Okay. And so this one is the one where your parabola will open down. And so your equation is the same as the equation on the left, and it's x squared is equal to negative 4ay. Okay. Now this is not really something you need to memorize, it's more kind of understanding. You already know y is equal to x squared is a parabola that opens up. So whenever you have x squared, you should know that it's the parabolas that open up and down. When you have y squared, it's the parabolas that open right or left. And then just, obviously, if it opens to the right or up, it's positive, and it opens to the left or down, it is negative. Okay? So now let's do examples with these forms of parabola. Okay? Now, example 4 on the back, it says to analyze the equation x squared is equal to negative 12y. Well now, which one of these cases, 1, 2, 3, or 4, has the form x squared is equal to a negative number plus y, or negative number times y? It's case number 4. It's this one right here. So look that you match this equation with the equation that they give you in the example. So I know I am going to do example 4. I'm going to do case 4 for example 4. Now, we're going to analyze the equation x squared is equal to negative 12y. Oh, and I should have mentioned earlier, whenever I say analyze the equation, it means find the vertex, find the focus, find the directrix, and graph. Okay. So, I have x squared is equal to negative 12y, and I know it follows the case 4, where x squared is equal to negative 4ay. So that means negative 4a is equal to negative 12, because I want to find what the a is. And so a is equal to 3. Okay? So now I know a couple of stuff. I already know it's in this form, so my vertex is at the origin. Remember, all of these equations only work for the vertex being at the origin. Since your focus is 3, and if you look at case 4, the focus is below the vertex. So that means my focus is at 0, negative 3. And then my directrix is going to be at y is equal to 3. Now let's find the lattice rectum. Okay, so now the lattice rectum. So whenever you have a parabola that opens up or down, instead of the lattice rectum going like this, your lattice rectum will now be horizontal. Okay? So what you're going to do is you're going to take the equation x squared is equal to negative 12y, and what are you going to plug into this y? You're not going to plug in what a is. You're actually going to plug in the y value for your focus goes into y. So this becomes And that's how you do it all the time. Whatever is in your focus, whether it's positive or negative, is what's going to go into the y or x, depending on what the lattice rectum is. Okay? So this becomes x squared is equal to negative 12 times negative 3. And so this is x squared is equal to 36. So x is equal to plus or minus 6, since we square root both sides. So if we graph it, okay, I know my focus, my vertex is at the origin, my focus is at 0, negative 3, my directrix is at 3, so I'm going to put here the directrix is y is equal to 3. And now your lattice rectum is x equals plus or minus 6. What that means is, look at your focus, and since it's x is equal to, I'm going to go to the left 6, and I am going to the right 6. So my lattice rectum is this distance here. And so your parabola opens down, and it looks like that. So that is how your parabola should look like. Okay. So now I want you to do the DIY on your own. So pause the video while you do it on your own. So for the DIY, you have the equation y squared is equal to negative 16x. If you remember, if you recall, since it's y squared, it's going to open either to the left or to the right. Since it's negative, I know my parabola is opening to the left. So it's going to have the form y squared is equal to negative 4ax. I make negative 4a equal to negative 16. And a is equal to 4. Most of you might be able to skip this step because you should be able to tell what a is, but if not, you should go ahead and work this out. I know since it's in this form, my vertex is at 0, 0. My focus, since it's in this form, my focus is to the left. So my focus is negative 4, 0. And my directrix is that x is equal to 4. So let's find the lattice rectum, the points of the lattice rectum. So the lattice rectum, it's going to be y squared is equal to negative 16 times negative 4. Because remember, well, here. Actually, let me rewrite this equation. Y squared is equal to negative 16x. I go back to my focus, and whatever that value is, I am putting here in the lattice rectum. So this becomes y squared is equal to negative 16 times negative 4. Okay. And then, so this becomes y squared is equal to 64. I square root both sides, and I get y is equal to plus or minus 8. And I'll leave the graphing to you here, but you should know the vertex is at 0, 0. Your focus is at negative 4. You have the directrix at 4, and then your lattice rectum is at positive 8 and negative 8. Actually, here, let me just do it. Here's your focus. No, here's your directrix. Your focus is right here. And I am going to go 8 above and 8 below. So it opens up like that. That is your parabola for the DIY. Okay? Now, if I look at example 5 is a little bit different because this time they don't give you the equation, they just give you a bunch of information and you're supposed to find the equation. So this is example 5. Example 5, you have the focus at 0, 4 and the directrix at y is equal to negative 4. So if I know the focus is at 0, 4 and my directrix is at negative 4, I know my vertex is at 0, 0. So I know I'm going to be using one of these equations. However, which one do I do? Well, if the focus is at 0, 4, that means my focus is up here, and then my directrix is down here. So I know this parabola is going to be one that opens up. So this is case number 3. So I know case number 3 has the equation x squared is equal to 4ay. And then in this case, I know my a is 4. So this becomes x squared is equal to 4 times 4y. And this becomes x squared is equal to 16y. So that's my equation. Okay. Now in order to graph it, I am once again going to find my lattice rectum. I'm going to take the value of the focus here and plug it into here. So the lattice rectum part becomes x squared is equal to 16 times 4. And that becomes x squared is equal to 64. I square root both sides, and I get x is equal to plus or minus 8. So now I just know that at the focus, I'm going to go 8 to the left, and I'm going to go 8 to the right, and your parabola will open up like that. Okay. So that was what we covered on Friday. We're going to do the rest of the packet on Monday. And so your homework was page 662, 22 through 28 even.